Hello again, back for random variable lesson number 2, rules for means and variances. This is probably the toughest lesson we have left here, so just a heads up, you may want to either watch this one in parts or watch the whole thing and then go back and watch certain sections, um, or rewind as we're going along here just to make sure you feel comfortable with it. And we can talk certainly more about questions as we get going here, and connect virtually or in person. So here we go. So first thing we have is we were talking about these probability distribution tables last video in lesson 1. And now we're going to start to dig into them a little more. So these are all discrete now, discrete random variables. These get actually a pretty decent section on your formula sheet. And the first formula we have is calculating mu. So we're again assuming that we have the population. And to calculate this, what we are going to do for these tables is again just now take the x sub 1 and multiply it by the p sub 1. So it's just the product of the value, the random variable value, times its probability. We do the same for the second one and add them up. We then add up the third one in there and so on until we got to the last one. And that's what this here is. So this is summation, or adding all up, of the random variable values multiplied by the probability values. Again, this formula is on your formula sheet with the random variables, and it's a mean calculation of a mu that we could ultimately use in a z formula if we wanted to. So as an x minus mu over sigma. So let's get into this a little bit with calculating a mu. And note, so I've put together an example here with a flight from Minneapolis, and I just picked a completely random city. For me was Las Vegas. And I looked at the prices for tickets on one flight to Las Vegas. So airlines use dynamic pricing, which means not every seat, on every flight is the same. And so what we have here, sorry, this should be probability and price should be there. Price should be there, and this should be probability. What we have here then in the economy seats is we're going to calculate a mean, and it's going to be mu sub e for economy. And all I'm going to do is what we were just talking about on the last slide, which is to take the price and multiply by the probability of that price. Okay, and we do the same thing here. So this means 40% of the tickets on this flight in the economy sold for $250. 35% of them sold for $275, and a quarter of them sold for $300, which would be those flight, if there's not enough seats or not many seats left at the end, they might move the price up a little bit, or maybe even the first few seats they tried to sell at a higher price. So what this is this is 100 plus 96.25 plus 75, and you add all those up and you get an average price then of so you take the, let's see, 175 plus 96.25, you get an average price of $271.25. Okay, so that was the average price that they sold an economy ticket for. We did the same thing for first class. Okay, so we take the first value, we multiply by its probability. So 40% of the first class seats sold for $375. 60% of them sold for $425. We take that, and let's see, we've got 150 here and 255 here, which means in the end that's a $405 average for the first class seats. Okay, so that means mu sub e equals 271.25, and mu sub f equals 405 as the average price for those tickets. Quick, we had, okay, I'm going to skip past this. It's going to use this for workspace as needed, but I think we'll just leave it as is here. And overall now, okay, so now we've got to look at the idea of manipulating means. So what we have found here is the average price for these tickets but now we've got the idea that we have a certain number of tickets that were sold in each section, and we may have some constant values. So here's what we mean by that. What we're looking at here, and this is not on your formula sheet, rule 1 for means, would be the notion of, let's just say that we have, I'm going to just go to an easier data set here, and just say that we have the data set 1, 2, 3, 4, 5. Okay. Now, the mean in this data set right now is 3. Okay. Now, B here is a scale factor. Okay. So a scale factor would be if I were to multiply all these values by something. So let's say I'm going to multiply each one of these values by 2. Okay. So I'm going to use a B equaling 2. So now this is 2, 4, 6, 8, 10. Now, what's my new mean? Well, my new mean is going to be 6. I know it's the median as well, but it's also the mean in the way that these are set up, of course. So when I doubled all the values, okay, that doubled my mean. Okay, that's what this means right here. This is doubling all the values. This means we're doubling the mean. Okay, so it's just the two sides of the formula. One is about the values, and one is about the mean. Okay, that's all this means here. Now, no pun intended, sorry. The A would be a constant. So let's just say that we add 10 to all the values now. Okay, so if I add 10 to all the values, now this becomes 12, 14, 16, 18, and 20. What's my new mean? And again, this was an A of 10. My new mean here is going to be 16. So again, what have I done? I've added 10 to the values, and what did that do to the mean? It added 10 to the mean. Okay, so that's a very kind of straightforward, what you do to the values, you do to the mean. Okay, now the rule 2 here. Rule 2 is about having two groups. Okay, so let's say I had group 1 was the 1, 2, 3, 4, 5. Okay, and group 2 was 3, 5, 7, 9, 11. Okay, so this is group 1, this is group 2. So group 1 has a mean of 3, and group 2 has a mean of 7. And again, calculating mean would be the stuff that we were doing on the previous slides if we had to calculate this the long way and with a table and so forth. Now what this rule is saying is if we have two different groups like we have here, okay, call this group X and this group Y. If we have two different groups, then if you add the groups together, and we'll talk more about what that looks like later on, then what you're doing when you add the groups together is you are adding the means. Okay, so adding the groups together here would be the idea of taking the 1, 2, 3, 4, 5, adding them with the 3, 5, 7, 9, 11. Again, we won't talk about how that's done yet, but all you're going to do in the end is then add their means together. So the mean of the new group would be 10. If this were subtraction, and these had minuses here, okay, then this would just be 3 minus 7. So you'd have a new mean of -4. So this would be mu of x plus y, and this would be mu of x minus y. Okay, and again, we'll look at these in examples more later on. Okay, so let's continue this rules for means, but with our example of the flight. So if you recall, mu sub e was 271.25. Mu sub f was $405. And we are going to figure out, on average, not just one ticket, but how much were we making from economy and how much are we making from first class. Okay, so in this particular problem, the 150 economy seats, that would be the B for the economy situation. The first class seats, there are 24, sorry, that's B sub F. So there's 24 seats in first class. And then we got to look at what A is. So A is $30 per passenger. But again, there's 150 passengers in economy. So it's actually $4,500 that we are getting as a constant from the economy passengers, just on baggage fees. And then we're looking at the scale factor of 150 seats times its old mean. So the amount of money that this airline is getting on just economy seats as a gross revenue here would be this right here, the A plus B times mu of E. Okay, and that ends up being, let's see, 150 times 271.25, and adding that to the 4,500. So they are clearing, I shouldn't say clearing, they are getting as revenue for those seats a value of $45,187.50. Okay, so that's mu sub 4,500 plus 150E. Now down here with the first class, okay, so first class, we want to find, let me get the darker blue here. We want to find mu sub. Now, there's 24 first class seats, and if they spent $30 on average a piece, that means they spent $720, which again is $30 per passenger, 24 passengers. They spent $720 just on baggage fees. So $720, and then there's 24 of these first class seats. Okay, so we know the airline's getting the $720 from the baggage fees, and they're getting 24 times $405 because that's their average ticket price. Okay, so 24 times 405, and you add in the 720. That means from first class seats they are getting $10,440. Okay, so that's rule 1 for means. We might as well just keep rule 2 right on here since we have the space. Rule 2 for means, again, is the notion of combining these. So that would be, in this case, mu of 4,500 plus 150E plus the 720 plus 24F, which is just a longhand way of saying how much money are they going to make total, not make, get just gross from these two sets of tickets. And that would be the $45,187.50 from the economy plus the $10,440 from the first class. Of course, we could combine or subtract however we wanted. If we wanted to see how much more money they're getting from the economy seats, we could do that if we wanted to. But more likely you're going to be adding these. And so they are, in the end, having gross revenue here of $55,627.50. So this is the rules in action. You probably could have done something like this without ever really thinking about what the rules were, but this is what allows us to do that. Okay, now let's see, here's our overall. Here was our overall mean right here. 55,627.50. So 55,627.50 was our mean. Okay, forward. We already did that, so we'll call that a check. On to finding the variance. Okay, so finding the variance is a little another level here in terms of kind of rigor, a little bit of busy work in there. And so what you do here is you have to actually run a formula that like this here. And again, this part of the formula right there, that is on your formula sheet. So let's just look quickly at what that is. And so essentially what we have is, if we look at, didn't want to do that. There we go. So if we look at this example here, we have 250 for X. So we have a 250, a 275, and a 300. Again, this would be calculating the variance. Notice that it is variance, so we have to square root it to get standard deviation if we want it, which we will want. So we put these in there, and we could multiply then these two, okay, to give us this value, and that's the, this added up would give us the mean, which again was 271.25. And so really what we are doing here to get just the standard deviation for economy, and I'll just leave it on this slide for now, is I'm going to take, I have a mean of 271.25, so I'm going to take my values, which would be x1 is 250. Okay, that's my first value in my table. I'm going to subtract the mean and square that. Okay, that's what I did right here, and then multiply it by the probability of that event. Okay, then I'll go on to the second one, and the second one here is 275. So this would be 275 minus the mean, square it, multiplied by its probability, which is 0.35. And then finally, the last one here is 300 minus the mean, square it, and multiply by its probability, which is 0.25. Okay, you could do this in lists if you wanted to make things go quicker, but this is what we are doing to get, and this is, again, this is all under that same radical. Can do that, continue it on if we want to. Okay, so what we have here is there's a difference of 21.25 or negative 21.25. Okay, and that is going to give me, let's see, I'll go back to black here. So the first term is 180.625 plus 4.92 about, and then finally about 206. Again, this is a lot further from the mean, so it's going to be a little higher, 206.64. And what this really is just kind of a weighted standard deviation. Okay, there's more 250 values, so that gets a little more weight. This one happens to be a little further away, so but it has less weight. Sorry, this last one, it's only 0.25 on this, and so it changes a little bit in terms of, that it carries less weight. There's fewer of those values because only 25% of the tickets sold for $300. Okay, so I'd add those up. And that would give me the variance, and then I take the square root, and that gives me the standard deviation. Okay, so this ends up being, let's erase that a little bit. This ends up being the square root of 392.19, which is a value of about $19.80. So all of this leads to a standard deviation, and you can double check this with your own calculations. Maybe you should. About $19.80 is how much these fares vary in the end. This would be the exact same thing as if you made a list of 100 numbers and 40 of the numbers were 250 and 35 of the numbers were 275 and 25 of the numbers were 300, put them in a list and ran one variable stats. It would give you the exact same standard deviation. This is just a shortcut version. So 1980 was the standard deviation for that one. Okay, now the rules for means and variances. So let's take that 1980. Okay, so as an example, again, the economy seats had a standard deviation of $19.80. Okay, so that's the standard deviation. Rule 1 for variances. Okay, if you recall, for the economy seats, we had 150 seats. So B was 150. Okay, we had 150 times 30 was how much we had in baggage fees along the way. Okay, now what you see in rule 1 here for variances, this is similar to means, but now we're just on the variance side. What you see in rule 1 is the constant. The baggage fees do not do anything to the spread because all they do is move our values down the number line. Okay, the values are no more or less spread out because of the baggage fees. The spread has to do with the number of tickets we sold at each price. Okay, so this is true all the time, that if you have a constant, okay, it's like if I had a set of numbers like 1, 2, 3, 4, 5, and I add 1,000 to each of those, that's not going to change how spread out they are. Okay, it will change their mean, but it does not change how far spread out they are. So that's why the A just goes away here. Okay, now to get the new standard deviation, you can see the calculation is actually in variances, so I have to take b squared times sigma squared. So the variance for the 150 times 30 plus 150, and this would be the sigma of E, okay, is going to be b squared, which was the 150 squared, times the standard deviation squared, which is the 1980 squared. Okay, now this is variance. Okay, so the variance here is 150 squared times 1980 squared, which would be 8,820,900. But we don't want that. This is the variance. We want the standard deviation, which is the root of that. Okay, and the root of that is about $2,970. Now, what does this value mean? This value means that on the economy seats, we found the average amount of gross revenue on the economy seats. This is how much the values vary. Okay, so we can expect them to vary. So in other words, on the next flight, they might make $2,970 more or gross revenue off of the economy seats, or $2,970 less, or whatever it happens to be. This is just on average. How much does the gross revenue for economy seats vary? That's what we're finding right here. Okay, now let's build this out. So rule 2 says, first of all, they do have to be independent with rule 2. Okay, and we'll talk about that more later. We don't need to add that in now, but what we mean is first class and economy seats have to be independent in our example. And what rule 2 says essentially is if we add up the first class and economy, or we even try to subtract the first class and economy, this always adds. Okay, so unlike means where we could subtract, here it adds, and it has to do with the squaring, and we won't get into that much on this, but we can talk about it later if you want to. Okay, so the squaring causes us to add. So let's just look at this in more detail. So we just calculated this, the sigma for the economy seats, I should say for all the economy seats. The sigma for the 150 economy seats was about $2,970. Okay, really quickly, let's figure out what we're going to get for the first class seats. Okay, so first we got to figure out what is the sigma for a first class seat. Well, that goes back to the actual calculation. 375 minus the mean, which was 405. Okay, so mu first class from previous was 405. We square that and we multiply it by 0.4. Okay, then we add 425 minus 405. We square that and we multiply it by 0.6. So this is just calculating the standard deviation now of the first class seats. Okay, so that ends up being, oh, and this is all square rooted. Okay, that ends up being the square root of 360 plus, let's see, 20 squared times 0.6, 20 difference there, is 240. And so that's the square root of 600, which is about $24.49. Okay, now we need to take this and figure out what is the standard deviation for all first class seats. So if you recall, that was 24 times 30 on the baggage fees, plus there's 24 times first class. Okay, and this was variance, using that rules for variances on the previous. I know this is getting a little more complicated as we go here, and I apologize for that. Again, the rule was the A goes away. Okay, that does not affect our standard deviation. So all we are going to do is take scale factor squared times standard deviation squared. Well, we know standard deviation is 600, so this is 24 squared. Okay, this is 576 times 600. Now again, if we want this to be standard deviation, then we have to square root and square root and square root. Okay, so we take the 576 times 600. Let's take the square root of that. And it turns out that the standard deviation here for this is about $587.88. So what that means is that for the overall 24 first-class seats, they expect to sell those on average for $405 with a standard deviation of about $24.49 per ticket. But when you look at the whole group, they expect that the overall gross revenue for the whole group would be that mean that we calculated previously, which was $9,720, give or take $587.88. So this standard deviation just represents for all 24 tickets, what's the standard deviation for our gross revenue? Okay, so they expect sometimes to get 500, 600 less than the 97.20 that we calculated for a mean, and sometimes to get that much more. Which means now, for Rule 2, okay, for Rule 2 here, it's going to bring this up a little bit. Okay, for Rule 2, that said that we just add the variances. Okay, so the variance of x plus y is just the variance of x plus the variance of y. Well, the variance for the economy is 2,970 squared, and the variance for the first class is 587.88 squared. Now, if we want this to be standard deviation, then we just have to square root that, which is what we would want in the end. Okay, so we take the 2,970 squared, we add that to the 587.88 squared. Okay, and this ends up being the square root of, let's see, 9,166,502.89. And so in the end, this airline has a standard deviation in terms of gross revenue of $3,027.62 for all of their tickets, economy and first class. That's 174 seats. We had previously found the mean revenue for all of those, and now we have the standard deviation for all of those. Okay, and that's $3,027.62, which combines here the first class standard deviation and the economy. Sorry, there was 3,027.62 was this standard deviation. Okay, so I've already combined, and I've already combined first class with economy. I just want to talk about, so the mean for all seats on this was 55,627.50, and the standard deviation for all seats, first class and 1,027.62. So this airline then, when they look at this flight from Minneapolis to Las Vegas, here's what they're looking at in terms of the mean gross revenue here with a standard deviation here. So the sort of question that could be asked about this would be something like, what are the chances that we have a gross revenue of under 50,000? Okay, so if the question is a gross revenue of under 50K, then what they would be doing is they would have a z-score that would be 50,000 minus the mean, 55,627.50, okay, all divided by 3,027.62. And we aren't going to calculate that right now, but this is the sort of question that a company would want to answer off of something like this, is they'd have their mean gross revenue and their standard deviation gross revenue, and they'd work with that. Now, of course, for airlines, this is going to change by time of year and things like that, and so they're going to look year over year and so forth, but that's what all of that work was calculating that. Okay, so we're going to skip over that. Now, in the end, standard deviation, Some other examples really quickly, hotel revenue. I had a student once who was very interested in hospitality, so we looked at two queen rooms and king rooms instead of first class and economy. You could do something as simple as daily 3 lottery tickets, SAT, math, and verbal to find out what means and standard deviations are for those. Golf scores, flight pricing is 1 week, and we did. Okay. One more thing here is a generic example, and this is I'm just giving some values just to use the rules here. So in this generic example, I give a mean and a standard deviation for the x's and a mean and a standard deviation for the y's. Included the variance in there, and so just really quickly here, going to look at what this example would look like. If you need a breather at this point, that's understandable, but this would be just employing all the rules. So in this case, if I wanted to find mu of 2x minus 4y, scale factor, so the 2 and the 4 is just using the scale factor. So that would just be 2 times the mean of the x and 4 times the mean of the y. That's rule 1, okay, for means. Rule 2 for means says if you have a subtraction, then subtract them. And so this would be employing rule 2 for means. So there's rule 1 and rule 2. So this would just be 14 minus 16 or negative 2. And that would be the answer to that. Okay. Now the standard deviation, of course, is a little more work. Okay. And this rule says, first of all, that you have to square the scale factor. So the scale factor here is 2 for the x. So I would go 2 squared times not just the standard deviation, but the standard deviation squared. So that would be this value squared. Okay, so that's rule 1 for variances. Then if I go to the other one, that's scale factor squared times the standard deviation for the y's squared. Okay, and again, that's rule 1 for variances that you're seeing there. Now, rule 2 for variance says we always add. And again, this is assuming these are all independent. So I'm going to make that addition. Okay, and now I can put some parentheses here. And then because I want standard deviation, I'm going to square root this. So this ends up being the square root of 4 times 9. Okay, 2 squared times 3 squared is 4 times 9, so that's 36. And this is what 16 times 64 is 4 squared times 8 squared. Okay, so that's 1024. Okay, so that's the square root of 1060. Or approximately, if you want to, and you don't have to even do this here, it's approximately 32.56. So this is kind of like what we did with the airlines. This is just no context, straight to it. Rule 1 and 2 for means, rule 1 and 2 for variances. Again, means scale factor just multiplies, and then if it subtracts, you actually subtract. Variances, you got to go scale factor squared times standard deviation squared, and then you always add there. And so that's the rules there. Notice I didn't put any constant in here, so there was no A in this example. You'd like to follow up on. All right, we'll leave it at that. Sorry for the length of the video, but thank you for your attention and for your persistence on this lesson. Take care. And I think we will leave it at that for now. I put a couple work slides in there, and then there's another example, but I'm going to hold off on the and look for now. And that's another example that you